level of illumination and pupil size. So in this video, we want to talk about the process that, the diameter of the pupil is changed. When we go to a dark room, our pupil get bigger and bigger. When you go to a bright place, like when you have a lot of lights, the pupil get smaller. The most, there is a lot of factors that can cause change of the pupil. One of them is love. That's very amazing for me. When I read about that, I saw that love is a kind of when you fall in love, the size of pupil changes. But the most important one is not love or the other factor like using drug. The most important one is the level of illumination, and the level of illumination can cause the change in size of the pupil of our eye. So the size of the pupil when we are in a very bright area is about 2 millimeter. Get very small, and then when you go to a very dark room, then the pupil size increase by 8 millimeter. So if you calculate, the variation in the area is about 16 times. So the intensity increases by that amount. So the total power increases by roughly that amount. So it's the size is a big number. 16 times the area is changing during when you go to a dark room and to a bright room. So the frequency of that kind of change that, for example, when you go to a room that you turn on and off the light, it goes like this. And the maximum frequency, the temporal frequency that we can, actually the pupil can get smaller and bigger is about 1.4 hertz, which is not a very big number, but that's actually very important that, that's the frequency of that change. And there is a lot of formula actually, but one of the most important one is the Moon and Spencer in 1944, that the D is the diameter in millimeter, the diameter of the pupil, and the L is the luminance CD over M squared, which is a unit for field luminescence. So based on that equation, we have 4.9 minus 3 tangent hyperbolic 0.4 log of 10 log to the base of 10 of L plus 1. Based on that equation, if you put all the numbers and those two coefficients, based on the change of field luminescence, you can actually find the diameter of the pupil. We have another equation by this research group that, we have log of D, which is equal to this equation, but the same scenario, we have pupil diameter, field luminescence, and if we put those two graphs on top of each other, you can see we have a pretty good match between the experimental data. You can see when we change the luminescence, the pupil diameter decreases. It's about 8 and then goes to 2. As I mentioned before, it's a big change. We start from 8 when this number is small. It means that you are in a dark room. When you are at the dark room, the pupil is big. When you go to a brighter room, the size of pupil changes. And we have these two models. And here are some references that I use. Thank you.